Hi, in this video, we'll look at what are the different types of collisions. Let's consider a few objects moving towards each other, and then let's assume that they collide. What will be the behavior and what will be the relative velocities before collision, after collision, and so on. As shown here, as you can see the couple of blue spheres, let's assume that they are balls made of rubber, and let's call this A and this ball as B. When these two spheres collide, let's say they are made of rubber, they are moving towards each other with velocities, let's say UA and UB. This is the initial velocity of A is UA, initial velocity of B is UB. They're moving towards each other and then they collide at some point here, and then after collision they start moving away from each other. So the velocities after collision, let's call them VA for A and VB for B. Now, if the collision is perfectly elastic, what do we mean by perfectly elastic? Let's say these balls are made of rubber, and then when they meet each other at this point, this sphere would press against this, and then there'll be some compression here, and this would press against this, there'll be some compression here, depression. And then they bounce back because they are made of good elastic material or rubbery material, that there is no permanent deformity or something that happens here, or dent that happens here. This pushes this away and this pushes the other one away, and then there is no loss of energy, or which we'll see a bit later. So basically it's a perfectly elastic bounce back by both the balls. Then in that case, let's see what will be the relative velocity of A with respect to relative velocity of B before and after the collision. So what will be the relative velocity of A with respect to B would be velocity of A minus velocity of B. This is before collision. This is the before scenario. Let's look at after collision what happens. Relative velocity of A with respect to B after collision would be, in this case, let's make a slight change. Let's take this direction as positive and this as negative. So this will be UA minus UB. Consider the direction. And in this case, velocity of A minus, which is negative, minus velocity of B, which is in the positive direction. So if it's a perfectly elastic collision, these two will be equal, which means UA plus UB in this case will be equal to minus VA minus VB, or we can rewrite this as V minus of VA plus VB. So this represented here in 1 will be equal to 2. So naturally, when you divide both of them, or rather the magnitudes of relative velocity, I'm writing it as RV so that we can identify it easily. After collision by relative velocity AB before collision, both will be equal. So it will be represented by a number 1, which is called coefficient of restitution. It's represented by the letter E. So if the coefficient of restitution is 1, then the collision is perfectly elastic.